Okay, this is going to be a real quick introduction to how distributions work in NetLogo. So I'm going to be using this in the histogram example on NetLogo, where it's a really simple model. If I jump over to code, I'm just going to have turtles owning an age value, and then those turtles are going to, once they're created in this initial model, we're going to be clearing all, so we're removing everything from previous model runs. And then every time we press setup, we create 100 turtles. And initially, at least, they're going to be all age 25. And then we're going to say update plots. And what update plots does is exactly what it sounds like. It updates all of the plots that we have on the interface command. If we were to say like tick, it would automatically do this. Tick does update plots as well as moves times forward. But just for our sake, we're just going to do update plots right now. So every time I click setup, right, you can see there's a bunch of little tiny agents right here, and that's because they're all centered on 0, 0, and their age is all going to be 25, right? Every single turtle is going to be the exact same age in this. So the point of this is to understand how random distributions work. So if instead of 25, I would just say set age random 100, right? So if I'm saying, all right, your age is going to be somewhere between 0 and 99, if I were to set age, we can see that, well, it looks like it's pretty evenly distributed. If I were to shrink down and auto scale this down to like 10, right? So if I were to shrink this down, oops, I want to shrink the Y max. So if I shrink the Y max down, it's kind of a little sparse in some and a little high in others, but it's pretty uniformly distributed. So it's a uniform distribution between 0 all the way up to 99. So that's what random 100 makes age look like. If instead I were to say something like random float 100, well, that's going to be producing a distribution between 0 and 99.9999999. And if I were to make that run, it's going to look pretty similar, right? Because I'm still using the same sorts of bins in this, so it's going to look pretty similar, right? It's all going to be uniformly distributed across this groupings. So what NetLogo, a benefit of NetLogo is that it already has a couple distributions built in. So if I were to do something, instead of saying like set age random float 100, if I were to say something like random normal, which is a pretty useful one, well, it's not going to like this because if I'm saying random normal, I need to give it 2 digits. I need to say the mean and the standard deviation. So random normal expected 2 inputs, a number and a number. So if I were to look at this up in the dictionary, looking random normal up in the dictionary tells me that, oh, I expect the mean and the standard deviation as the 2 numbers. So what I want to give is I could say something like 50 and then let's say 10, right? So if I were to say, all right, 2 digits, and I say, all right, all the turtles set your average age is going to be somewhere around 50 with some standard deviation around that mean. And then, unsurprisingly, what we get is something that looks an awful lot like a standard distribution, right? There's going to be variation each time we click this because it's random, right? It's going to look different every single time. But it's going to be, on average, about the same. The mean is going to be right around 50 age with some little variation on the tails. If I were to like shrink this, right, if I were to say like the standard deviation is 50 and 2, right, we're going to get something that looks an awful lot more like a skyscraper, where there's not that much standard deviation, there's not much variance in what that age is. And if I were to do something like 40, right, that'd be a lot, right, a really high standard deviation, it's going to be a much more spread out normal curve, right? Looks almost even uniform because it's so spread out. So that's what random normal is doing. It's producing a normal distribution. And we can have other options. We could also do exponential distributions. And if I look up random exponential in the distributions, well, I'm not actually going to be giving a standard deviation because that's not what a exponential needs. It only needs a mean. The average exponential distribution is only going to be one number. So if I say exponential 50, and saying, all right, most of them are going to be at 50. If I were to shrink this, it could be a little bit more easy to see. If I say at random exponential with a mean of 10, right, an exponential distribution shows that on average the value is 10, but there's going to be a lot below it and a lot above it. That's what exponential distributions look like. I could also be talking about something like a gamma distribution. So if I were to say gamma, in gamma distributions in the dictionary, I need to give both an alpha and a lambda value. So if I were to give something like a alpha value of 50, so this is just part of like a gamma distribution. If I were to set this up, I would have the gamma distribution being 50 and the beta the values being 50 and 10 for that gamma distribution. That shows that most of them are going to be really, really low, with occasionally there's going to be really high ones that are there's probably even ones that are like off the screen. But it's just a distribution that's what gamma is. And the last one that is already built in is going to be a Poisson distribution. When we're talking about Poisson distributions, again, it's going to be one number, where we're saying the average distribution is going to be around 50 with a little bit of variance on either side. We could set this value to be something closer to like 10 to be more realistic to a Poisson. And it's going to be something similar to something like a normal distribution, but it's more closely matching the Poisson. So these are just different distributions that are already built into NetLogo. We're going to be talking in class about how you would use the toReport function to build in your own distributions. Things like distributions that are not already supported in NetLogo, either because they're rare or something like that, or because just nobody ever really uses them, and they're specific to whatever you're doing. So we'll be talking about that in class. I'll see everybody in lecture.